Good afternoon, everybody. This is Spring XD Internals, a guided tour. We are David Turanski. I am David Turanski. I'm full-time on XD. I was thinking we're back-end developers here, so they put us at the back end of the conference down in Ballroom G. So I want to thank you all for coming, making the trip down to this room to hear us talk about what we do. Prior to XD, I was a committer on Spring Integration. I was a lead on Spring Data Gemfire for a while, and also done a lot of consulting and played different roles, and mostly in the enterprise systems integration space. I want to introduce my colleague.
Hello, everyone. Can you guys hear me okay in the back? All right, so my name is Peralta. I'm also a developer on the Spring XD team. I'm kind of one of the new guys on the team. I've been on the team since about January. The last place I was prior was at Oracle, where I was an engineer on the Oracle coherence team. So I had a bit of a range of roles there, including development, support, and kind of everything else in between. So some of my interests are in distributed systems, concurrency, networking. Basically anything having to do with sockets and threads is pretty cool for me. So that's about it.
Thanks. So we're going to start with a brief review of Spring XD. How many were at the last session in here just now? So you saw some of it, and we assume you've heard of Spring XD a little bit. We're gonna cover the basics pretty quickly, and then get into an architecture overview, drill down a little bit on how XD was built, and then Patrick's going to talk about the distributed runtime and the role of ZooKeeper specifically. And then we're going to look at some ways of extending XD, but probably the most common use case is building a custom module and installing a module into an XD runtime. So we're going to focus on that at the end, and then we have a nice demo for you. So this schematic here shows XD and illustrates some of the concept. So we have a stream which processes data. It doesn't end. It's got some events or some type of polling from a source that's coming in, and it can go through a number of processing steps, and then eventually outputs to a sink, which is something external to XD. It's capturing data, ingesting data into HDFS, for example, or passing the data onto a legacy system. So that's a stream, and a stream is composed of modules. So what this is showing at the bottom, we have some source and a pipe going to some sink. And what that would look like in XD is if we have a distributed configuration, we have two containers. When that stream is deployed, the source will be deployed to one container, one JVM, and the sink will be deployed to a separate container instance, and these will be communicating via some transport. The transport is pluggable through an abstraction we call a message bus. We have an admin node that is used for deploying and undeploying streams. For example, if you were here at the last session, you saw the admin is what supports and actually executes the commands from the XD shell. And the admin and the containers, the whole XD cluster communicates using ZooKeeper. I'd call your attention to the diagram on the left and the mirrored part on the right, showing the container module. The source module is deployed to its own Spring application context. And a source module must have an output channel. And the sync module has a corresponding input channel. Now what happens during deployment is the message bus kicks in and builds adapters, outbound and inbound adapters for the specific transport that's configured. By default, Rabbit is the recommended. I'm sorry, Redis is the default, but Rabbit is the recommended transport for production as being more reliable. Redis may be faster, but you don't have persistent queues and things like that. You have and acknowledgement and transactional kinds of things that you have in Rabbit. So we provide Redis, Rabbit, and other transports are possible. Now, when we talk about modules, we're talking about a component that's reusable. It's got a name, so for example, HTTP, Rabbit, log file, things like that. Type of module is a source, processor, sink, or job. And we're going to focus on the first three, which are used in stream. So as you said, a stream must have a source and a sink, and it could have 0 to n processors in between. They're simple, reusable components for streams that are built with Spring integration. And so they're basically Spring integration message flows that follow certain conventions. So the source is a message producer. It produces messages to its output channel, goes across the transport, and then the consumer receives the message. And the sink is the consumer, or a processor is also a consumer and a producer. As I mentioned before, each module lives in its own application context. So as we'll see during this talk, we do a lot with creating application contexts internal to XD, but this was kind of a big idea that originated with Mark Fisher, was that if we have a Spring integration flow that's running in it or defined and runs in its own application context, we can have something like a file source, which is simply, in Spring integration terms, a file inbound adapter. So it's pulling some directory for new files that come along, and the module itself is capable of either outputting the file itself, the file object itself on the output channel, or the contents of the file. So that's configurable. So if you have a module called file, you may want to configure it each instance differently. So you have one that's pulling some directory foo, and another one's pulling a directory bar, and those are parts of different streams, but it's the same Spring bean definition. And because they live in their own application context, a couple of things are possible, which make things really nice. First of all, we can have different property values instantiated for each instance. That's a nice aspect of this. We also can use simple names like input and output as conventions for the channel names without having bean name collisions. So if everything is in one application context, how many people have used Spring integration? I've built applications with Spring integration, a couple, but in a large application with Spring integration, you can reuse parts of it, but typically you would have some type of integration flow, and you would have to qualify those channel names. They can't repeat because they're bean IDs, and so the bean IDs, they'll either overwrite each other, or if they're in the same XML bean definition, you'll get an error that says you have duplicate bean IDs. So having these things contained in application context means that we can, each message channel called input and output is really its own instance, and can have the same ID within that application context. This allows also better encapsulation and lifecycle management. So modules, message channels, and Spring integration endpoints are implemented in an interface called Smart Lifecycle, so they can be started and stopped. And so if we have a separate application context, we can start and stop those application contexts independently. So this gives us a lot of flexibility and control. Module is implemented, it's an interface implemented by Simple Module currently. And if you look at the code in Spring XD, it's Simple Module. It's basically using boot to load and configure the application context for the module. So let's look a little more at the architecture. So XD can be configured as a distributed application, which is what you want for production when you're scaling out, or single node, which is very useful for demos, testing, and things like that. We've got a lot of tests in our test suite that just start a single node and, and test streams and various things that work in that environment. So on the left side, we have a XD-admin and multiple container instances, and the modules get deployed to those container instances, and we require a remote transport. In the case of single node, everything is embedded in one process. So we have an admin instance, we have a container, all the modules get deployed to the same container in the same JVM. We have an embedded ZooKeeper server in there and an embedded HSQL database to support the Spring Batch repository. So you just start single node, and by default, single node uses local transport, which means direct channels and in-memory communication, but you can also set the transport on the command line, for example, say -- transport when you start single node, and you can use Redis or Rabbit, so that will actually do marshalling, serialization between modules and invoke that transport. So very, very good just for testing things out and in a simple configuration. The container itself has a couple of different key components. One is a container registrar, and that's the guy that talks to ZooKeeper and registers itself with the ZooKeeper cluster. So when a container starts up, and Patrick will get into more of this, but I'll just mention it here. It's connected to the cluster. It's a client, and it says, "Here I am," and creates a node in ZooKeeper so that the admin can keep track and says, "Okay, I got you. I can deploy modules to you now." And the container registrar also handles requests that requests are like undeployment and deployment events that are also triggered by ZooKeeper nodes appearing or disappearing. Module deployer is something that deploys and undeploys modules. And it initializes a module application context, and it actually invokes plugins that handle the setup of the module. So this is kind of an interesting point. The container itself is something that's distributed, that can run in a cluster, that knows how to deploy and undeploy modules. A module is just a Spring application context. It's a black box to the container. The XD container itself doesn't know anything about streams or jobs or message buses. This is all handled by plugins, and these plugins get discovered on initialization. Anything that is in the class path, or any bean that's not in the class path, but any bean that implements the plugin interface is loaded into the container, and so that the module deployer is responsible for invoking that plugin. And it's the plugins that actually do the work of XD. And I think it's kind of a subtle but important point, because I think what we would like to do eventually is take the XD container that we call DIRT, the Distributed Integration Runtime, and use it to build basically an HA environment for any type of Spring application. It doesn't have to be specific to XD, but right now they're pretty closely coupled in the way they're packaged. So the plugin, just to give you an idea, the interface looks like this, and We have, when we talk about module lifecycle events, there's a pre-process module. This is when the module's been initialized, but before it's actually been started. We can do something to that module. We can post-process that module after it's been started. Remove the module when the module is when destroyed, and before shutdown, for graceful shutdown, what do we need to do? And then there's also a supports method. So if you write a plugin, you can say implement supports as a Boolean. So if you want to work on every module, if you want to do something that your plugin wants to do something that every module that gets deployed, then you could just return true. But the job plugin, for example, looks for module type as job, and stream plugin looks for module type as sync, processor, or source. And as I mentioned, the container discovers any bean that implements this interface, and XD has some that it requires to work, specifically the stream plugin and the job plugin. And you could also register custom plugins pretty easily. And I was going to come up with some demo for that for this talk, because I think it's kind of cool the way that XD can be extended, but I don't see a lot of use cases for actually writing a plugin. But if you need to, it's very easy. You implement plugin, you can register a bean in a certain point in the class path, a certain resource location, like meta spring xd/plugins. You put a XML definition there, for example. XD will pick that up if your jar file's on the class path. So the other component that's really very central to XD is the message bus. And this is used currently both by the stream plugin and the job plugin. And basically, for a stream, when a module gets deployed, the message bus is responsible, or the stream plugin is responsible for invoking the message bus to bind this output channel, which is typically just a direct channel. So you say in Spring integration, XML, you would say channel ID equals input, channel ID equals output. There's some flow between those internally, but it's a black box. But the stream plugin will query that module and say, okay, give me your component type message channel that's named input, and I'm going to create an adapter on the fly for this to bind it to a Rabbit queue or to a Redis queue, for example. The message bus is also responsible for binding tap points and named channels that are associated with that stream. So you can tap a stream at any point before every module. If you want to tap the source, you get a copy of whatever messages are coming in the stream to do real-time analysis, for example, or you can tap it after some transformation has happened. And so those tap points are actually named channels in XD. And you could also create a stream with a named channel. So you can say HTTP greater than q:/foo, and that's a named channel. So these things all get bound by the message bus to the transport. The other thing the message bus has to do is take care of the marshaling. So if you're going over Rabbit or Redis, any type of remote protocol, and you have a POJO, you might need to do some serialization. The message bus has some optimization, so it says, okay, if it's already a byte array, I'm not going to do anything to it. If it's a Java object, I need to serialize it, and we use cryo, which I think is the correct pronunciation currently. That is somewhat configurable, but not so much by end users yet. But we could certainly look at doing that if there's a demand for using other serializers. So cryo is what you get out of the box. Mention that the The container obviously makes use of the message bus at runtime. The admin uses the message bus to launch a job. So if you say job launch on demand, you just want to launch this job right now, a batch job. The admin basically sends a message to the jobs channel as waiting to hear, say, okay, I can start. So the message bus is a shared component by the admin and the containers. Other transports are easily pluggable, as I mentioned, and I did prepare some code for this, which is at the Spring One GitHub repository. If you're interested, we really don't have time to walk through this, but if you want to see kind of a bare bones JMS message bus, it kind of illustrates this project illustrates sort of how it's plugged in very easily. Writing the message bus is a little bit more involved, but kind of gives you an idea and something that works over JMS with an embedded active MQ server in single node. So I'll refer you to this link if you want to see how that's done. I talked a little bit about application contexts in relation to modules. XD itself uses a fairly complex application context hierarchy. And there's kind of a reason for this, or several reasons for this. One is, as I mentioned before, we have the distributed and single node implementations of XD, and those use the same exact Spring configuration that's internal to the XD runtime. So we split things out in a way that they could be combined for a single node with an embedded admin, et cetera, or distributed where you have a process that just does admin functions and another process that has the means for the container. There's also a feeling that, well, if we had a single application context, that modules that were deployed or plugins that were deployed could see everything, could have access to say the ZooKeeper beans that could control the runtime. So potentially a security issue, but we also don't want people that are developing with XD to shoot themselves in the foot. So we want to isolate those beans and not expose them to the extendable parts. Also, the plugin context itself is designed to be extendable. So one aspect of XD, since it's a runtime and not really a framework, when you build with XD, you're not creating the application context itself like you do with a normal Spring application. We create the application context, and as you see, it's kind of sophisticated arrangement using boot. So there has to be some hooks where we say, okay, well, you put your Spring configuration in a well-known place. We have sort of custom component scanning or mechanisms that look for certain types of components in certain locations to allow you to add any kind of arbitrary Spring application or Spring beans to the application context. These go into the plugin context themselves, and ostensibly would be used by a custom plugin. So if you had some plugin that was doing something with Gemfire and you wanted a Gemfire cache instance, you could use Spring Gemfire to create, to start up a cache in XD and use the plugin or plugins or have modules that take advantage of that in some way. I just want to quickly show you how this is done with boot. So this is single node application .java, and it's got a main. And inside here, we're using this Spring, the boot Spring Application Builder, which is a Fluent API for creating application context. So you can see you can add listeners, you can set up profiles, initializers, you can create child contexts, you can create siblings. So you see the admin is a sibling to the container context. So all this stuff is getting set up in the single node application. in one process. So what you get from this admin call, when you say admin run, you get back a context which is actually the last child, which is the admin server application, which is configured. So if you look into this some more, all of this in XD is a combination of Java config and XML. And so I just wanted to point this out as a application of boot. We're doing some very sophisticated things with the boot API. And so I'd say, yeah, boot passes the test of making simple things very simple, but complex things possible as well. At this point, I want to turn it over to Patrick to talk about the runtime. Oh, I think, yeah, one more. Yeah, I just want a quick summary. So we talked about you can add a custom module, and we're going to do a demo of that, so I won't say much about that. Possible to plug in your own transport, message bus. Like I said, I did a prototype JMS transport. We're working on a Kafka message bus right now. I think they're back there coding it in the back there as we speak. You can add a custom plugin if you need to do something with every module as it's being deployed or undeployed. And you can add any kind of bean definitions to XD. If you're interested in more about this, you can go to our wiki or to the reference guide in the Extending XD topic.
All right, thanks, Dave. So most of the components in Spring XD are based on pre-existing projects in the Spring portfolio. So your Spring Batch, Spring Integration, and so on. The distributed runtime is kind of the new kid on the block. So we're going to talk a little bit about how it works, how we put it all together, how we string together the modules to create streams and jobs. So thinking about the requirements that we have for our runtime, first and foremost is the ability to deploy modules, obviously, and the ability to undeploy modules when necessary. Since we expect this to be a dynamic system that can be scaled up or down on demand, we also need the ability to know when a new container arrives, and the flip side of that is we need to know when a container leaves so that any work that container was doing can be deployed to any other container that is running in the system that meets the qualifications to host that module. So when I first joined the team, the way that the runtime worked was basically built on a dedicated message bus that they would call the control bus. And what would happen is when you're typing on the shell to deploy a stream, the admin would put a message on the bus that says, somebody somewhere go deploy this. So it would just throw these things up on the queue, and whatever container happened to be available would pull stuff off the queue and deploy the module. So that fulfills the first requirement. That doesn't really fulfill the second or third requirements because the admin actually doesn't really know. I guess the admin can know if somebody picked something up off the queue, but it doesn't know if it actually succeeded in deploying the module. And it doesn't know if that container does succeed in deploying the module and later on that container fails, the admin doesn't know anything about it and doesn't have the ability to take any action for it. So fortunately for 1.0, we've solved this problem, and now the admin is a lot smarter about how modules are deployed. So it's able to actively select certain containers to deploy modules. If you don't have any specific criteria, then it's going to do a round robin similar to what we did before with control bus. You can do things like indicate a certain number of modules. I think that Mark did that in his previous talk where he showed multiple HTTP modules, for instance. So you can indicate a minimum count for them. So of course, if a container is shut down and the stream is still deployed, then we will take that module and we will make an attempt at deploying it elsewhere. Additionally, when a container shows up, the admin is going to kind of examine the state of the system, and if there are any modules that need to be deployed to complete a stream, then it will do so at that time. One of the other nice benefits that we have now is the ability to calculate stream state. Since a stream consists of multiple modules, there is no one single place that you can really check to see what the status of a stream is. So the admin has to kind of be able to query the various containers in the system to see what the state is of a stream. So we're able to do that initially when we deploy a stream, but if you lose an admin and it comes back up, it has to then recalculate that for every stream to determine what's the actual state of the stream deployment. So when we talk about multiple admins in a Spring XD system, usually the term that we use is the supervisor for the leader admin, and this is the one admin that can make decisions on where things are deployed and the handling of arriving and departing containers. So in addition to those functional requirements, you had a question? So the question is, what role do the other admins play? So there's two things. So if you have multiple admins, then you could imagine doing something like, say, setting up a load balancer in front of them for the REST API. So in other words, you can point your web application or your shell to a load balancer, and that can then pick an admin to send commands to for deploying, undeploying, and so on. The other thing that you get out of that is redundancy. So if you lose an admin server, then you still have another one that can pick up the responsibilities for issuing deployments and for watching containers come and leave the cluster. That is correct. The leader is going to be the one that makes the decision. That's correct. The good news is that it doesn't matter for you as the end user. You don't have to pick which one is the leader. And that's actually something that we're going to talk about, how we accomplish that. So the question is this a standard ZooKeeper deployment? You mean, I'm sorry? Quorum? Yeah, so we'll talk a little bit about ZooKeeper quorums momentarily, just to understand how it all fits together. So this is a distributed system, and distributed systems have certain non-functional requirements that don't necessarily relate to the functionality that we're looking to build, but we need things like leader election, for instance. We need the ability to pick a single system, a single actor in the system that can make decisions as a whole for the entire cluster. We need the concept of consensus. In other words, making sure that all of the VMs in the system come to an agreement on some kind of value that you're setting. The other thing that we need that's really important is the ability to detect failure in a process, at least in terms of the system as a whole. Being able to determine, is this container alive? Is this container available to do any work for us? So just really quick talking about the ZooKeeper. So the way that I would describe it is it's kind of a toolbox that you have as a developer to build distributed systems. So when you're working with it through its API, it kind of looks like a file system or like a hierarchical database where you have nodes that you can create, and each individual node can have a set of bytes associated with it. When I say that it mimics a file system, I mean that it's not really a file system. So typically, you don't want to exceed 1 megabyte per node in a ZooKeeper in the ZooKeeper Z node. We don't go anywhere near that. We just put very small amounts of information in each, which is really the best practice for using ZooKeeper. So we were talking about quorums. So in a typical ZooKeeper production setup, you're going to set up multiple dedicated servers that are running ZooKeeper servers. And typically you're going to have an odd number of servers because any updates and by default any reads from ZooKeeper require a quorum of servers. So if you set up 5 servers, then at least 3 of those servers have to be up and be able to see each other in order to make any progress on reads or writes. If that quorum is disrupted, then no reads and no writes are going to occur on ZooKeeper. It also has guaranteed order delivery for updates. So what that means in practice is that if you have a process and a thread that sends update A followed by update B, it means every other member of that system is going to see update A before it sees update B. It's not going to get those out of order. So you also have the ability to register for updates. Is what ZooKeeper calls a watch. So you can basically say, instead of polling for changes on the node, you can ask ZooKeeper to notify you on a background thread whenever any changes are made to a specific node. And finally, one of the really big things that we take advantage of are ephemeral nodes. So what that means is a client, the ZooKeeper, can create a node and mark it as ephemeral, meaning that when that client closes its connection, or if that client goes away, if something happens to the machine, then the node that it created will go away. And that mechanism is very useful to know which machines are available to do work. In terms of how XD itself uses ZooKeeper, so we use it as a centralized storage for stream definitions, job definitions. So if you were to create your streams and jobs and shut down your XD cluster, shut down ZooKeeper, ZooKeeper keeps everything in memory, but it also persists it to disk. So if you bring the whole thing back up, then you won't have to recreate your jobs and streams because they will already be there. It keeps track of which containers are available for doing work. And it emits notifications for when containers come or leave, and emits notifications for when end users create streams or jobs. Mark Fisher and I, when we created the initial prototype on moving XD to use ZooKeeper, we tried using the ZooKeeper API directly. And we also made a prototype using a library called Curator, which is part of the Apache umbrella of projects now. Curator was actually created by Netflix, and it was created to have a kind of a nicer API to run on top of ZooKeeper. The ZooKeeper API itself is pretty low level, and handling failure conditions is a bit tricky. And I don't really blame ZooKeeper for this. It's just kind of the nature of the problem is a bit challenging. So we created this prototype at first with just ZooKeeper, and then we created a prototype with Curator. And the Curator prototype had about maybe 1/3 of the code, and it already had some data structures that we created by hand, which no doubt ours had a lot more bugs than the Curator one because Curator gets a lot more usage. So that's what we use internally for working with ZooKeeper. So one of the subtleties that you don't notice when you're first working with it is the handling of connection state. So Curator gives you 4 states. It gives you the connected state, which is what you get initially. You get a reconnected state if you lose your connection and you get reconnected. And then there are 2 states that it emits for connection loss. The first one is suspended, and what that means is that you are no longer communicating with a ZooKeeper server, but your session with ZooKeeper, aka your ephemeral nodes, are probably still there, but we don't know. But they're probably still there. If you get a lost event, it means not only is your socket connection broken, but we know for sure that your ephemeral nodes are no longer there. And the handling of that event is going to have an effect on your availability. What I mean by that is what we're doing now in containers is if we get a suspended event, it means that we probably have a temporary disconnect from ZooKeeper. It means that we're going to, as long as Rabbit is still up or Redis and the rest of your infrastructure is up, we're going to let your stream continue processing, even though we can't talk to ZooKeeper right now. On the other hand, if a lost event is raised, then we shut down the module, shut down the application context, and clean everything up. The reason that we do that is because if we get a lost event, there's a good chance that, that the leader admin is going to select a different container to run the module that you are already running. On the other hand, for the admin, we treat suspended and lost the same way. And the reason for that is because we expect that there is a single admin and actually a single thread in the entire XD cluster that is making decisions about deploying things to containers. So we definitely do not want multiple leaders making those decisions. In fact, XD, assuming that everything has been deployed, you could technically run XD without an admin server, assuming that your streams are up. The consequence of that is if you lose a container or add a container, then no action will be taken. But we're better off with no admin than we are with multiple leaders making decisions about deployments. So for us, it's that aspect of it is very important. And I think you had a question about sort of the leader election and the quorum. One distinction I wanted to make is that ZooKeeper internally has its own leader election that has nothing to do with us, and it has nothing to do with end users of ZooKeeper. But the curator library includes what they call a leader election recipe that is used, that is basically this leadership election API that is built on top of ZooKeeper. And that's what we use in the admin to select which one is going to be making the decisions. Some interesting ways some interesting things that we've done to test this. The simple and obvious thing is to do Control-C. Anybody can handle that pretty much. Kill -9 is not a big deal either. The difference between the two is if you do a Control-C or a regular kill, we have a shutdown hook that is going to cleanly close the connection and clean up any ephemeral nodes. So you'll see the container leave right away. If you do a kill -9, then we obviously don't get a chance to clean up. And it's going to require the session timeout for the ephemeral nodes to go away and consequently for XD to realize that the container went away. Control-Z is a cool way to do testing in a distributed system. As Control-Z is suspending the process, meaning we're not killing the process, we're just going to kind of pick it up and put it in the background. And that's a great way to simulate a full garbage collection from the point of view of a distributed system, because you'll have other nodes in a system that are trying to send data to this guy and they're not getting any response, but the socket connection hasn't been broken. So that's a good way to sort of simulate what a full GC would look like from the perspective of the other nodes. Not necessarily of that node itself, because if you had a full GC in real life, then you'd probably be burning a lot of CPU and you'd have other problems to deal with. But the last two are kind of some interesting tests that we did. If you ever want to have fun with with a network application, establish your socket connection, get everything going, and then if you're running on Linux, then set up an IP tables firewall rule to drop packets for that individual socket. Because what's going to happen is two things. One is that you're not going to lose your TCP connection, so the client and the server is not going to realize that there's anything wrong. Second, you're not going to get any data. So this technique was what we had to use to get Curator to emit disconnected versus lost events. So if you do this for a little while, then you'll get a suspended event. And if you don't clear out the firewall rules and just leave it alone, eventually then you'll get your lost event, and that's where the session will go away. So and one other thing that we did is bringing up a ZooKeeper ensemble and disrupting quorum just to see what happens. And everything gets really, really confused when that happens in a nutshell. But at least in my testing, eventually when you bring the quorum back to life, things are a bit strange for a while, but after about a minute or so, everything kind of settles down and everything goes back to normal, and your modules kind of go back to processing the way that they were before. So I'm going to pass it over to Dave, who's going to talk about developing custom modules, and hopefully we'll get that demo going for you soon.
So I'm going to talk about developing modules for a stream, and so I have a qualification up here. So I'm not going to talk about job modules. We have sync, source, and processor, and job are the 4 module types that XD currently supports. Job modules are written in Spring Batch, and if you're interested in more information, there's a lot about that on our wiki, also in the reference guide. Also, I'd encourage you to go hear Michael Manella's talk tomorrow. He's going to demo a recommendation engine that uses Spring Batch with XD. So that should be pretty interesting. So we're going to talk about a few things: the module registry, the kind of artifacts you have to provide for a module, and some of the subtle differences that are required for source processors and syncs. And then finally, Patrick will demo a source module that he wrote in preparation for this. Spring XD 1.0 uses a file module registry. So, of course, it's a Spring app, so module registry is an interface. And it looks for the presence of modules that can be deployed. And file module registry is pretty much located wherever you install XD. What we refer to as XD home is actually the root installation directory /XD, and then under there's a modules directory that looks something like this screenshot on the right. And so if you look at the source, and I picked one kind of at random, syslog TCP source, so that gives you syslog information as it comes over a socket. And you can see there's a config directory, and that contains the XML definition of that source, and also a properties file. The properties file can either point to a module options metadata class, which is an annotated POJO that gives you some level of validation and information about the options or the properties that the module supports. So when I mentioned earlier the file source, that would have a directory option, which would be the path of the directory that you're polling for the presence of new files. And that module option has a name, dir in this case. It has a type, and it has a description. And so the metadata that's provided gives you some auto-completion hints in the shell, for example, so you know what those properties are about and which ones are supported, what types are supported, and things like that. So the properties file could point to a module options metadata class, or it could have inline property definitions that say dir.type, dir.description, for example, and a set of those. Also, you have a lib folder, and that requires any custom code that's needed to support that module. So the module definition itself, in this case, uses Spring Integration IP and Spring Integration syslog for those adapters. So that's what's needed. We're looking at a lot of work in this area. As Mark Pollack mentioned in his last talk, we're looking at improved packaging using boot, which has some sort of Uber jar where all the dependencies and all of this stuff could be packaged and installed as a single jar. Right now, it's not that sophisticated, but so these things have to be copied somehow. We have, as Patrick will show you, some Gradle tasks that do that and make it easier. In terms of artifacts, we do require XML. How many people like XML? Okay, good. I do too. We do. Spring integration traditionally is well suited towards XML. So we did module definitions in XML, and it's fairly easy to load. At a minimum, if you want to do Java config, you have to set up your component scan, and you can do the rest in Java config. And we're working on alternate representations for the next release. You also typically would require some type of custom code. So that would be a jar that if you're, say, writing a processor that's doing something, and you need to write some code in Java. For example, in Spring integration, you would have a processor could be implemented as a transformer. So you have a class and a method that's backed by that transformer, and that binds it to the input and output channel. So we'll see that in a minute. But if that code is going to be executed at runtime, it needs to be in the XD class path. So you would put that in the lib folder. And then any dependent jars, as we saw, if it's using something in Spring integration or in Spring or some other dependency, needs to be in the module's lib directory. We'll mention that there is a module class loader, so we have this sort of parent last kind of class loading scheme. So it looks in the lib folder for that module for classes, and then if it doesn't find it there, it looks in the system class loader, which is pointing to xd-lib and all the jars in there. So the jars have to be in one place or the other. If you have something that's shared by multiple modules, you may want to go ahead and copy it right into xd-lib at this point. Sometimes that is required, depending on what type of class loader issues we have. But as I said, there is a lot of work in this area, and if you're interested, I'll point you to Eric in the back of the room. He can answer any of your questions. So I want to talk about, say, a custom processor module, which I mentioned is probably the most straightforward. So if you had a stream and you wanted to do HTTP source and a custom processor called my processor and pipe the output to a file, you could provide an XML, which is a simple, very fine-grained integration flow. And so, as we see here, you can implement it as a simple transformer with a bean class called my processor. If that class has a simple one method, a single method that returns an object, it qualifies as a transformer, and you just bind it to the input and output channels. And as I mentioned before, the channels are specifically named input and output, which is a convention for XD. So processor must have both an input and output. So fairly straightforward if you want to do a processor. Also fairly straightforward is a sink. Now, a lot of times a sink would be backed by an existing Spring integration adapter. So I think we said this morning or one of the previous talks, we don't have a SMTP sink. So today you cannot send an email out as a result of some stream. I don't know if you'd want to do that for a big data application, but maybe in the use case we were talking about, we have a batch job that failed. You want to send an email, and that could be handled with a stream that's monitoring the result of the batch job execution. And so that could make use of as an SMTP sink. So you would use just an existing Spring integration adapter. You wouldn't have to write any code, and you would just give it an input channel in this case. So yes, we do have it. That was quick. No, good. Yeah, we do have it. So if there's an existing Spring integration adapter and we don't have it implemented yet, you can do it and just bind it to a channel called input. The output goes into a black box somewhere in a sink. It's external to external resource to XD. But I was thinking, well, if you're doing some legacy integration and you want to have a stream that's feeding some system and it's got some interface, you can use a service activator. You can write some code that knows how to work with your legacy APIs, and you could just feed it this way. So not too difficult. When Patrick decided to take on was the most challenging, of course. So a source is kind of working continually. It's either polling or it's triggered by an event, and so it's actively looking and waiting for events to happen. Most of the out-of-the-box sources we provide in XD do use existing Spring integration inbound channel adapters. But of course, Patrick wanted to do something that wasn't supported directly, and he'll show you that in a minute. And so, if you want to have a POJO as backed by a source, you need to have some knowledge of Spring integration. And there's basically, it's becoming easier and easier. But when we started this, we could either have what's a generic inbound channel adapter, which has to be configured with a polar and can be backed by any POJO. So if you look at, say, the cafe example in the classic Spring integration literature, it uses, or some implementations that use an inbound channel adapter, and so it can say invoke this method, pull this class, invoke the method every so often, every second or whatever. But that takes a lot of work if you don't really know Spring integration, and we want to make this stuff simpler. But that's one approach. Another approach is you can have your class extend message producer support, and we have an example of this which Patrick wrote, which is the XD source template in the GitHub repo. So you can take a look at that to see how you could do your own thing. But at this point, I'll pass it over for the demo.
So I'm kind of a big fan of vmstat on Linux. If you've ever run vmstat before, it basically just prints to standard out a bunch of stats that you would normally be interested in, such as CPU usage, memory usage, disk usage, and so on. So if you were to type something like vmstat2, it means every 2 seconds it's going to print this output out. And obviously there are more sophisticated monitoring tools that you can use, but for something quick and dirty, it's kind of nice to have. So I thought it would be kind of fun to write a custom source module that will take this output and feed it into Spring XD and allow you to do what you would normally do with a stream. So as Dave was mentioning, I'm not going to go through all the code here, but basically what it comes down to is I have this callable, or you can use a runnable, that is going to be creating output, and it's going to be feeding it into the bus using this send message. And this send message is inherited from, where is it? Is inherited from this message producer support class. So you take message producer support and extend it. What I'm doing here is simply using the Java process builder to call vmstat and reading the output, creating a tuple, which is our simple data structure key value store, and basically parsing the output and stuffing it into this tuple and sending it into the bus. That's pretty much all that it does. So we can kind of run it and take a look at what it looks like. So first of all, before you start an XD cluster, you need some infrastructure. So what I have here is my RabbitMQ server. Down here I have a relational database, HSQL, which technically we don't need it for streams, but right now XD requires it to start up. Eventually we may modify it so that if you're not running jobs, then you don't require a SQL database. And then ZooKeeper over here. So that's kind of the bare minimum that you need for a distributed cluster. So we'll start up the admin, get that going, and once that's up, we'll start up a couple of containers as well. So, okay, so the admin is up. So we'll start a few containers on running on my laptop. And we can see there's one so far. And we've got two. So one of the challenges that I had was VMstat produces wildly different output and not really all that useful, in my opinion, on Mac OS X as it does on Linux. So this particular module that I built has to be run on a Linux machine. So I do have an SSH connection here to a Linux machine, and I'm going to start a container here as well. So while that's up and running, one thing I wanted to show was the configuration file was this configuration file for the Linux container. You can set this up in as a command line parameter, and I think this is what Mark did in his last talk. In this case, I decided to modify the YAML file. So you can attach attributes to a container. One that we support out of the box is called groups. So the idea here being that you may want to put your containers in certain groups so that you can target certain modules to certain groups. In this case, I created a group called Linux, and this container, when it joins, it's going to indicate that it's part of the Linux group. So if you do runtime containers here, we can see that unlike the other containers in the system, this one has Linux indicated as part of its group. So I'm going to create this stream called the vmstat pipe log. So very, very simple. And when I go to deploy it, I'm going to specify that the vmstat module must be deployed on the Linux container because it's not going to work on the OS X containers. So we can see over here that vmstat was deployed on the Linux container. The output was actually, the log was actually deployed on the OS X container. So what's happening here is the vmstat output is getting put onto Rabbit, and Rabbit is delivering it over to this container. So if we were to kill this container, then the output stops because there is no source. And if we do a list of this, if we do a stream list, we can see that the status of it is failed because we don't have the source module. So let's start it back up. And when it starts back up, we should see the supervisor over here notice that this new container came up, and hey, it's capable of picking up this orphaned module, which it did, and therefore we get the output over here again. So I'll flip over really quick and kind of give a quick tour of ZooKeeper. So if we do a list of containers, we can see that our containers are present over here. So we'll do something fun over here, which I wasn't anticipating, but you know, it's a demo. You got to take a risk. Let's do no, that's a thread dump. I didn't want to do that. Let's do a Control-Z. I'm going to stop the process over here. So in the meantime, I'm going to show you the streams. Oops. Right. Streams. So we can see that our vStream is there. If we get the actual data, we can see that the definition is stored in ZooKeeper, right? If we do a get xd deployment streams, then we can see the deployment properties are over here. So we can see now that there's only 2 containers over here because this guy went to sleep for way too long, and we based in ZooKeeper expired its session and removed its ephemeral node. So if we bring it back up, then we see the session expired event over here. And now that it's come back to life, it's come back from its full stop the world GC, pretend GC. So it's reconnected, and if we do a runtime containers, then we can see that it came back. So if we do a undeploy v, then if we do a list of the deployments, then we're going to say no, does not exist because it's not deployed. On the other hand, if we do xd streams, then we can see that the stream definition is there. So that's something that I kind of wanted to emphasize is you have properties for streams that can be specified at the definition time, and then you have properties that are specified at deployment time. And that's the reason why we make the distinction. And we actually used to, by default, deploy a stream as soon as you created it, and we stopped doing that for this reason, is because we anticipated that users would want to provide specific runtime deployment information that you wouldn't necessarily know at the time that you create your stream definition. Does anyone have any questions? Yeah. Oh yeah. Yeah, absolutely. Mm-hmm. Yeah. So let's see. So if we were to go, so this is our Spring XD home. So if we were to go under modules, we can see the job, processor, sync, source, and so on. So we'll go into source. And these are the modules that we ship with out of the box. We can see VMstat is over here. For convenience sake, I actually made VMstat a symbolic link, thanks to Eric's great suggestion here, because what this is actually doing is a symbolic link straight into the output directory of the VMstat project. So if we go in here, then we can see that there's a config and a lib directory. I don't remember if I have anything in the lib directory. Well, okay, so obviously my module is in there. I don't know why Commons Math is in there. That's weird. So if we take a look inside of config, then we can see the XML config, and in this case it's really, really simple. It just has this output over here, which is just setting up the output channel. The definition of my bean, and 2 properties. We set auto startup equal to false. The reason that we do that is because we want to be sure that the message bus channels have been established before this thing starts up. Otherwise, we'll get some errors on the console. And we're just tying the output channel to the output channel that's defined up above. And that's pretty much it. If you take a look inside of our GitHub repo, then you'll see this, and you'll also see a template project where you can literally just do a search and replace for a template and put in the name of your module if you want to create your own source module. Anything else you can think of that would be good to look at? Yep. Cool. So any questions on, yes?
That's why I got confused with sync dynamic because
Yeah, we also have what's called stream partitioning, which we haven't shown. Maybe we'll see some of that. But that's another way where we can actually partition, have a partition algorithm instead of partition the stream directly so that like messages go to the same instance stuff, same downstream module.
Yeah, so you have the ability to examine the data that's coming into the stream and basically pick which partition it belongs to, and it can be routed to a specific instance of a sink that way.
another question is, can you have a model that receives more than one type, more than one source of the particular model input, more than one input channel?
The question was, can you have a module that can collect more than one source?
For example, in storm streams, you can say this module here has using the module for string XD, multiple input channels, right? So you have two modules sent to the next one.
Yeah, it's multiple. Yeah, that would be handled, I think, by named channels as well, pretty elegantly. So you could have a queue channel that's an input where you have streams multiple streams that output to that queue. So you'll just get, and then a single stream that processes things coming from those multiple sources. Likewise, you can set up name channels as prefixed with topic : so that you can have a stream that actually can fan out to multiple substreams. So a lot of these things are possible, but definitely we're interested in feedback from the community on features that we should add there. Any other questions? Are the modules hot deployable? Yeah, they are, because the module registry is looking at a file location. So if that module exists and is configured correctly, but if it's already deployed and you change the module definition, it's not going to pick up the new. So it's not really hot deploy. So if you already have a module deployed and then the stream is running, and you put in another jar file in its lib directory, you're going to have to undeploy the stream and redeploy it manually to get that changed. But if you add a new module and you want to, it's available just by dropping it in the module directory.
I think at some point where we were considering the ability to redeploy individual modules in a stream. The underlying infrastructure supports that, but we don't expose that at a high level today. So today, if you were to, and I kind of had experience in developing this custom module where I would make a change and I would want to see that change reflected. And the only way that I was able to do that today is to undeploy the stream and then redeploy it. I didn't have to destroy the stream. I could keep the stream definition, but if I undeploy the stream, the application context is thrown away, the associated class loaders are thrown away, and you go to redeploy, then it'll pick up the new jar that you just dropped in, and that'll work just fine.
So that comes up.
Yeah. Was there a question in the back? Yeah.
Are there other user interfaces available to ZooKeeper besides the command line?
The question is, are there any other user interfaces for ZooKeeper other than the command line?
There is one.
I think that there are some UIs for ZooKeeper. I haven't used them myself directly, but I think that some of my teammates have seen some. I haven't looked at it all that much myself. I haven't had a need for it personally. And if we do our job right, hopefully you won't need it either, at least for our project. That's kind of, the stuff is out there if you want to look at it, but my goal is to avoid the requirement for end users to go poking around in ZooKeeper and looking around. It's there if you need it. You kind of think of it as the Windows registry, where all of the bits are there, and if you really know what you're doing, or if there's some horrible bug that you have to work around, you can go in there and make any changes to it. But by and large, I would hope that going through the shell or going through the admin UI would be sufficient. And as a normal course of operations, hopefully end users won't have to go into ZooKeeper to do regular maintenance for XD.
I would add to that. We saw the shell command like runtime containers or runtime module. Those are backed. The shell command is backed by a REST endpoint that's supported by the xd-admin. So you have the URL of the admin. You can write a REST client directly, and that's what the xd-admin UI is such a REST client. We anticipate there may be others in the future, but the xd-admin in 1.0 is more around batch job management and less around stream commands. But going forward, we want to have parity between the UI and the shell. But right now, there's more stuff in the shell.
Now that you mention it, that reminds me that some of the automated distributed tests that I've created for the project, which launches VMs and kills VMs and so on, none of the asserts for those tests actually read ZooKeeper. They do everything through the REST API. So things like deploy this stream. I don't go into ZooKeeper to assert that it was deployed. I go through the REST API. Same thing for containers. If I kill a container, then I do the runtime containers command through the REST API, and I use that to assert that that the container actually did die, the one that I intended to kill. So that's kind of our hope. In the real world, of course, we'll introduce bugs, mostly me. So. There may be a chance. There may be, there may be some times where you have to go into ZooKeeper directly to clean stuff up. But that should be an exceptional case, I hope.
The ZooKeeper configuration, is it readily available? Like my machine, if I'm already using ZooKeeper.
So the question is, if you're already using ZooKeeper, we actually anticipate that a lot of people will, because we expect that XD is going to be used in a Hadoop environment, and there are other Hadoop projects that already use XD. So we anticipate that you already have ZooKeeper running, then you would just point XD at your existing ZooKeeper ensemble, and you're good to go. Yes?
Why do you recommend to do debugging? If you deploy an application on Spring XD, to debug that application, what's the best approach?
The question was about deploying and debugging, say, a stream. Well, it kind of depends on the stream itself, but we have a pretty good test harness that we run. So for one thing, you can set up a unit test that starts a single node application, and if you look in say in XD-dirt, that module, and look at how the unit tests are done, you can deploy a stream using, we have pretty good support for testing that way, just for functional. But if you're talking about more distributed type of race conditions, it gets a little more complicated.
Install, I create a local topology. I run this local topology from my ID, for example, and then can go line by line and see how the components are talking to each other via this local topology. Then when I deploy in a real distributed environment, I just replace local topology by the topology itself, and then I deploy something before. So I was thinking if you have something similar on Spring XD that has this kind of topology.
Yeah, I don't think we have anything like that sophisticated, but we do have various testing support that we've provided and experimented with, and some of them are useful for example, if you want to test a module, deploy a single module and just test it, you're getting an input and outputs. We have some classes that we expose that make it very easy to basically put that, send a message to it directly, specific data, and see what you get out. in a test class, for example. But in terms of actually watching where it goes through the system, or things like monitoring it very closely, we don't yet have anything that sophisticated.
Well, the nice thing too is that it's all plain Java, so you get to take advantage of all of the infrastructure and all of the testing and debugging stuff that you get with plain Java. So I've done things like just attach a debugger, a remote debugger, to a container, and I've been able to step through it that way. Of course, in a distributed system, that is easier said than done, because if you're on a single node, then maybe it's one thing, but if you have a whole bunch of other processes in the system that are depending on each other, then you can get weird things happening. Especially in a kind of system where you're actively monitoring and making sure that your containers are still up and running. For instance, if you run in a distributed environment, you have 5 containers, you decide to attach a debugger to one, what's going to happen is when you start stepping through your debugger and you start going slowly, guess what? You're not sending any heartbeat messages to ZooKeeper. So eventually ZooKeeper is going to decide that you're dead, and it's going to cut you off. And you know.
Best is for testing the functionality of the application, right? It's not for testing in runtime, in distributed way, just test if the system locally is doing what's supposed to do. It's like when you run a unit testing for all of your modules together, and you see that one module is sending the data to the other one, that's keeping the thing doing the first of making it.
When there's JVMs available, you can actually go in and see as one module is executing something, did it send to the next module, how many times did it send to the next module. So you can utilize JVMs and put it into Spring. It's just JConsole in, and we have you can go in and actually inspect each module.
It's perfect that you found Glenn, because he is kind of the testing guru, so he can answer any of your testing questions. Any other questions before we wrap up? Yes. I don't know when it is, but yeah, I'll be there.
Yeah, we're running a little over. I think we'll be here if we want to have a discussion offline, and we'll be around. So thank you very much for coming.
Yep.
Enjoy the rest of the show.
Yeah, enjoy dinner.